We are back again with the last 10 sets of questions, which will properly cement our understanding of problem solving and algorithm design within computer science. Actually, the first question is asking us to define problem solving in computer science. Well, when we talk of problem solving, this is a process of analysis or analyzing a problem and developing a step-by-step solution. So this is a process of this is a process of problem analysis and developing a step-by-step solution. I think basically that is problem solving within the computer space. Explain why algorithms must be written before coding. Well, algorithms, they help in saving time that's needed to do actually the development of a solution itself, as well as eliminating errors in the process. So algorithm, they help in a clear solution. So algorithm, they help in clear solution development, eliminating 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 errors and program development and coding time. So these are some of the benefits of writing algorithms. What they save us, especially on time, it becomes very, very optimum. Writing algorithm to calculate the perimeter of a rectangle. So if we want a perimeter of rectangle, we're interested in data that we want to input for us to process and come up with the output. So we can start the process, then input the dimensions, which are length, breadth. Then next is the process where we are defining a new variable. We can call it, well, let's call it perimeter, because here we are interested in perimeter. Then we can say perimeter is twice length plus breadth. And when we say twice, we need a product there. Then after that, we want to output perimeter. Then we stop the process. I think that will be it for this particular algorithm. Write pseudocode to input two numbers and output the larger. So we can again start. Then what do? We input variables num1 for number one and num2 for the second number. Then we are now doing a comparison to say if num1 bigger than num2, then output num1, else output num2. Then we end if and actually stop or end the process. I think basically that's it on the algorithm to, I mean, that's the pseudocode to do a comparison of two numbers. We check which one is bigger of the two. Then we end if, then actually we stop. Then next, we are interested in writing a pseudocode to check if the number is even or odd. So here again, we are going to start the process. And when we start, we are going to input where we receive the num or number. Now, once you have the number, because we want to check whether it's even or odd, we are now going to say if there's a condition, num mod 2 equal to 0. So if it happens that we divide a number by 2 and the result is 0, then we can output that this particular number is even. Else, output the number is odd. Then we end the if, then actually terminate from the code. Then next we are interested in drawing a flow chart to input a number and output its square. So we input a number, that's from the flow chart. So we start the process with an oval chart where we say start. Then when we are receiving information or outputting, then we can move with an arrow to a rectangle, then we say num. This is the number that we have input and we want the process which is squaring it. So we can go down and bring a rectangle and say num times num, which is the square. Then we can proceed to the output, which is a parallelogram again, to say this is square. Then we can terminate the process to say we have found our solution, then we stop. Now, number 7, name the 3 flowchart symbols and their uses. So we said the oval is start or stop of the process. We have a diamond, which is a decision to be made, especially when we want to change the direction of flow of our instruction. Then an arrow, it shows us flow of program execution. Then we're moving to the next one. Trace the output of an algorithm when input is equal to 5. It looks like here is an insufficient question. We don't have the proper question there. Explain one common mistake when writing algorithms. Now, when we are writing algorithms, it's very, very important to make sure that all the necessary information required has been included. So a common mistake is missing steps or forgetting to close the end if and else statement. So common mistake is missing loop closure, such that we have a program which does not terminate, or sometimes just missing important information as you solve your problem. State one reason why flowcharts are useful. Yeah, both flowcharts, they give us a visual representative. It becomes easier to read. So they give visual representation is easier to interpret. I think basically that's it on algorithms and problem solving for IGCE O level. I hope you guys you found it interesting. Let's meet again in the next discussion. Thank you.